All right, class, we are getting into chapter 3 today, and we're going to finally get into what Mrs. Burton calls the nuts and bolts of algebra. We're going to learn how to transform and solve equations. Now, the key to what we're doing today and tomorrow is we are going to use inverse operations. So we're going to look at addition and subtraction, and we're going to look at multiplication and division, and how to use those ideas to solve equations. Now, when we get started on these in chapter 1, in section 1 and section 2, Mrs. Burton calls them one-steppers. It's going to take one transformation, one move, for me to get my variable alone so I can solve for it. And so as we go through here, we're going to see these different properties of equality. What key word do you see in equality? Yes, the word equals in there. And if you see that, it's like on every one of these properties of equality. So that's an important thing to realize. Now, if you look at my beginning statement, it says if A, B, and C are any real numbers and A equals B, then for me to use the addition property of equality, here's what that looks like. Okay, if you notice, it says what I add to one side. If I add C to one side, then I have to add C to the other. That equal sign is kind of like our pivot. So whatever we do to one side, we must do to the other. What about the subtraction property of equality? You guessed it. What if I subtract C from one side, then I have to go ahead and do the exact same thing from the other. What about the multiplication property of equality? That's right. If I multiply one side by C, then I have to do the exact same thing to the other side of the equation. Then our division property of equality, you got it. If I divide one side by C, I have to divide the other. So if you notice here, whatever we do to one side, we have to do to the other. Now, our goal in this idea of transforming equations so we can solve them, I kind of break it down into two parts. Isolate the variable by using inverse operations. If you were on a deserted island, what would that mean? Yes, you're all by yourself, and that's what we need to do. We need to isolate the variable. What's a variable again? Yeah, it's a letter that stands for a number in an equation. And so we need to get that letter alone. And how we get that letter alone is by using inverse operations. What can undo subtraction? Yes, addition. So addition and subtraction, addition and subtraction are inverse operations. And then what can undo multiplication? Well, to undo or be the opposite of multiplication is division. All right? Now, again, Mrs. Burton said we're going to call these guys one-steppers because it's going to take one transformation to get the letter alone to solve. So let's see what that would look like for us. Let's go ahead and everybody copy down in your notes problem number 1. Yeah, when I look there, number 1, we need to isolate the variable. What is the variable? Yeah, the variable is P. We need to get P alone. So if you look up here, what should we do first? Well, most would say, hey, Miss Burton, parentheses, do me first. But when I look in the parentheses, there's a variable in there. So there's really nothing in the parentheses for me to do first. But there is something on the left-hand side of that equal sign that I can do. Do you see it? Yeah, I can add -9 plus 1. Well, -9 plus 1 is -8, and then we've got -8 plus P equals 5. Now, we still need to get P alone. So, to get P alone, who needs to move? Yes, -8. Now, Mrs. Burton likes to call -8 the floater. I say, who's the floater? The floater's the letter or the number that's not attached to our variable. So what is the inverse or the opposite of negative 8? Positive 8. Nice. Remember that addition property of equality. Whatever I add to one side, I have to add to the other. So let's see what happens when we do that. Well, these guys are going to cancel out. They are additive inverses of each other. So I'm left with P equals. Now, let's look over here on the back half of my equal sign. We've got 5 plus 8. They're the same sign, so that means we're just going to add them, and 5 plus 8 is 13. Now, we got to show complete work and check our solutions. Checking is so important. Well, how do we check? Well, we're going to take our P value and plug it back into the original. I've got negative 9 plus parenthesis 1 plus P. Well, P's 13. See how I'm plugging it in where it belongs, equals 5. Now, how do we check? Oh, now parentheses do me first. Well, in the parentheses, we've got 1 plus 13, which is 14, equals 5. What's negative 9 plus 14? Right, so we get 5 equals 5, and that is my check. Okay, so do you understand? Isolate the variable, get P alone by using inverse operations. Nicely done. We first solve, and then we check. Let's go over here and look at Mrs. Burton's number 2. If you look at my number 2, we've got 11 equals 32 minus y. Now we need to get y alone. So who needs to move to get y alone? Yes, I would say 32 is my floater. So when you look there then, what's in front of that 32? There's nothing there. That means it's positive 32. What's the opposite of positive 32? That's right, negative 32. Remember our subtraction property of equality? What I do to one side, I do to the other. And so now these are going to cancel. Oh, but if you look, these are opposite signs here. If they're opposite signs, what do? Nice, subtract and put the sign of the greater. All right, so we've got negative 21 equals negative y. Now we have a problem. When we solve that variable, when we isolate the variable by inverse operations, when I get him by himself, he needs to have a positive understood 1. The problem here is I have a negative in front of the y. So how can I get rid of that negative in front of the y? What property did we learn back in chapter 2? Nice. We can use the property of negative 1. Remember, we saw if I multiply things by negative 1, it changes everybody's sign. So that's going to give me 21 equals y. Okay? So again, when I get y alone, it's got to be a positive understood 1. So that's my final answer. Now, I need to check it, so here we go. We've got 11 equals 32 minus y. And what was y? It was 21. So now, what's 32 minus 21? It's 11, and so our problem checks. Nice job. So do you see what we mean now by saying they are inverse operations? Addition and subtraction undo each other. They are inverse operations. Okay, now we're going to go over here and let's look a little bit at multiplication and division. So everybody go ahead and copy in your notes number 3. Ooh, I hope you notice something as you're copying it down. Yeah, so look. Parentheses do me first. There's a letter there, but what's in front of the parentheses? Do you see it? Yes. Remember, when I have that negative sign in front of the parentheses, that means the opposite of everything behind it. So the first thing I need to do is I need to rewrite this problem. We've got 1 equals negative 2, and now we've got to take care of the opposite of what's in parentheses. So what's the opposite of 4? Well, that's negative 4. What's the opposite of negative w? Positive w. Okay? All right, so now, do you see some like terms we can put together? Yeah, what's negative 2 minus 4? That's going to be negative 6 plus w, and we still have equals 1 over here. All right, so now we still need to get w alone. Who's my floater this time? Yeah, negative 6. What's the opposite of negative 6? Positive 6. Addition property of equality. What I do to one side, I do to the other. So we get w equals y. Now remember, we've got to always check our work. So here we go. Here's my original problem. 1 equals negative 2 minus parentheses 4 minus 7. Oh, parentheses do me first. What's 4 minus 7? Negative 3. So what's negative 2 minus negative 3 equals? Oh, do you remember? We've got to add the opposite, so this becomes plus and plus. So now we've got 1 equals negative 2 plus 3, so 1 equals 1, and that's my check. Nicely done. Okay, I'm going to erase some of that so we have some room to see the next problem. So let's go over here and look at number 4. Now, we need to get c alone, but this time we have a fraction in front of it. How am I going to get c alone? Yes, remember that c needs a positive understood 1 in front of it. So we learned back in chapter 2 that if I multiply 5/8 by its reciprocal, 8/5, everybody cancels out, and now I have 1c. But what I do to one side, I need to do to the other. So this is going to be 8/5 as well, multiplied by the reciprocal. Now, Mrs. Burton always puts her whole number over 1. Do you see some things we can cross cancel? 5 goes into 5 once. 5 goes into negative 20, what? Negative 4 times. And now what's negative 4 times 8? Negative 32. Nice. We always check our work. So here we go. We've got 5/8 times negative 32. I'm going to put that over 1. That's my c. I just plugged it in. Equals negative 20. So let's look at our multiplication of fractions. Do you see something we can cross cancel? Yeah. 8 goes into 8 once. 8 goes into negative 32. What? Negative 4. And now 4 times 5 is negative 20 equals negative 20. There's our work and there's our check. Okay, now let's remind ourselves and look at something in number 5. Who remembers what these brackets stand for in number 5? That's right. Those are absolute value brackets. So, for me to solve this problem, before I can solve for A, I need to get those brackets alone. So how am I going to get A alone? Who's attached to A? Yeah, that fraction bar. That fraction bar means what? Division. So what do we need to do to get rid of that 8 in the denominator? Yeah, we're going to multiply both sides by 8. These are going to cancel. And so now I've got the absolute value of A equals, well, 4 times 8 is 32. Now, here's my question for you. If absolute value is the distance something is from 0, how many numbers are 32 spaces away from 0? Right. There are 2 numbers that are 32 spaces away. So A is going to equal positive and negative 32. Remember, positive 32 is 32 spaces to the right. Negative 32 is 32 spaces to the left. If you wanted to, you could write it like this way as well. Positive 12 and negative 12. All right? Nicely done. Now, let's go over here and let's look at a story problem. Oh, yeah, story problems always and forever. So write an equation based on the facts of each problem and then solve the equation and the problem. So story problems, always and forever, mean our 5-step plan. Okay? So if we're going to solve this using the 5-step plan, let's see what we got. It says 3/4 of a number is 2 1/7. Find the number. So remember, our 5-step plan, step number 1, what are we solving for? Well, it's written right here. It's the last sentence. Step number 1, we're supposed to find the number. Okay, step number 2. Step number 2, I need a let statement. Well, if we're supposed to find the number, guess what I'm going to make my let statement be? You guessed it. I'm going to let n equal that number. Now, once we get this far, who remembers the most important word in this sentence that Mrs. Burton always boxes? Nice. I always box is, because we learned that is means equal. Nice. Does anybody see my operator word? Remember those operator words we memorized and looked at back in chapter 1? It's a really small word. Do you see it? Very good. Of, what does of mean? Of means multiplication. Nice. Now, we're hoping that you realize 3/4, okay? 3/4, hopefully you realize that's a fraction. So everybody look at my equation. Does that make sense? 3/4 of n, remember multiplication, I write the fraction right by the number, equals 2 1/7. Now, what do you think we need to do before I can even start solving that equation? Nice. That's right. We need to take that mixed number, 2 1/7, and we need to change that to a mixed number. Do you remember how we do that? Yeah. The denominator times the whole number. 2 times 7 is 14 plus 1 is 15/7. All right. So now I took my 2 1/7 and I changed it to an improper fraction. Now, how do we get rid of that 3/4 in front of n? Yes, we multiply by the reciprocal. Okay, that's what I did right here. And so they all cancel each other out, and we've got 1. But what I do to one side, I do to the other. Okay? Now, if you notice here, I've got some canceling I can do. 3 goes into 3 once, and 3 goes into 15 5 times. And then we've got 4 times 5, which is 20/7. Everybody understand how I got my answer? Good job. Now, let's look over here. Here's my check. All right, 3/4 times n. Here's n. I plugged it in. And then we did some cross-canceling. This is 1, and this is 5. So 3 times 5 is 15/7, and 2 1/7 is 15/7. So it checks. Very nicely done. Okay, one more slide, and then we're done. Okay, let's write an equation based on the facts of each problem, then solve the equation and the problem. It says 225 students play a team sport at Oaks Christian Middle School. These students represent 3/8 of the total student population. How many students attend the school? Okay, so what are we trying to solve for? Yeah, we need to find what? How many students? We need to find how many students. All right, so I said let T equal the total number of students that attend Oaks Christian Middle School. All right, now, a little bit tricky this time because it doesn't say the word is. All right, there is a number up there we need, but does anybody see my operator word? Yeah, we kind of made sure everybody knew that from the last one. We've got of. What does of mean? Of means multiplication. So we know 3/8 of the total student population equals 225. Everybody see what we did? Yeah, that seems easy now after we did the first one. Now, how are we going to solve that problem? How do we get rid of that fraction? Yeah, remember, we're going to multiply by the reciprocal, so all that cancels. So now I've got 8/3 times 225/1 equals T, because we got rid of the 3/8. Now, can we cross-cancel that? Well, 3 go into 225. Let's check it out over here. Remember, no shame doing basic math. So that's going to be a 7. 3 goes into 22 7 times. That's going to be 21. If I subtract, oh, it does. 3 does go into that. What do we got? Yeah, 75. Okay, so this goes once, and this goes 75. And now T equals, well, we need to know 8 times 75. So let's go over here and do some more basic math. 8 times 5 is 40. What's 8 times 7? 56. Plus 4 is 600. So T equals 600 students. All right, now make sure you show a check. We always show a check on our story problems. So we've got 225 equals 3/8 times 600 over 1. And I promise it checks when you get done. So I want you to take some time to start your homework. Do a really good job keeping up with all your signs. And let's see if you can isolate the variable by inverse operations.